Hi, I'm Mohammed Hussein, a computer science student at MSA University. Today, we'll explore the divide and conquer strategy in algorithm analysis and design. Our agenda includes an overview, algorithm design exercise with analysis, and a practical game to enhance understanding. Let's get into it. Divide and conquer is a problem-solving approach that entails breaking a complex problem into smaller, more manageable subproblems. These subproblems are solved independently and their solutions are then combined to address the original issue. Let's take some basic steps of divide and conquer strategy. Divide, break the problem into smaller, more manageable components. Conquer, solve each smaller component independently. Combine, integrate the solutions of the smaller components to address the original problem comprehensively. Let's get an example. Our example is a quicksort. First, how it works. Partition the array by choosing the first element as the pivot, then apply quicksort recursively to each subarray. Combine the sorted subarrays to obtain the final sorted array. In this code, our base case is when the length of the array is less than or equal 1, we going to return the array because it's nothing to sort. If the array is not less than or equal to 1, create two temporary empty arrays, left and right. Initiate a for loop starting from index 1 to the end of the original array. Use index 1 instead of 0 as the first element serves as a pivot. Compare each element with the pivot. If it's less than or equal, append to the left array, otherwise, place it in the right array. Employ recursion by passing the left array, pivot, and right array to the same function for further sorting. Upon completion, combine the arrays into one sorted array. Let's get into the analysis. First, we have T of n is equal to 2T of n over 2 plus n. And the 2Tn over 2 is equal to 2 of 2T of n over 4 plus n over 2. So, the T of n is now equals 2 of 2T of n over 4 plus n over 2 plus n. Let's do some simplification of the equation. The T of n is now equals to 4T of n over 4 plus 2n plus n. T of n over 4 is equal to T of n over 8 plus n over 4. Then our T of n is equal 4 of 2T of n over 8 plus n over 4 plus 2n plus n. It looks like we found a pattern, then we generalize. But first, let's simplify our equation to 8T of n over 8 plus 4n plus 2n plus n. In general, after k iterations we get T of n equal 2 power k multiply T of n over 2 power k plus k, n. Now when n over 2 power k equal 1, it means it reached the base case, then we have k equal log n, so we get T of n equal n T of 1 plus log n multiply n. And since the T of 1 is constant, then we can simplify the equation to n log n. So, the overall time complexity of quicksort is O, n, log, n. Now the funny moment. Let's play game to see how this algorithm works. Start with an array of 7 random unsorted values. Select the first element as a pivot and create two empty arrays, one for values less than or equal to 3 and the other for the rest. Now we have sub-arrays and each of them going to make the same sequence to sort their array. Let's get into the left array first. It going to take a pivot of the first element like we did in the original array. Then trying to sort the same way. And after finishing it appends the pivot at the middle of the array. Now the right array, it took the 8 as a pivot and tried to sort the same way. But it's already sorted so nothing happens, so it appends the pivot at the middle of the array. Now after sorting the subarrays, let's combine the first pivot by inserting it into the middle of the two subarrays. Now it's how it looks like after the sorting. Now take a look of before and after the quicksort. The end. Hope you like playing this game. In essence, the divide and conquer approach intelligently tackles significant issues by breaking them into more manageable components. This boosts computational efficiency, streamlines problem solving, and is applicable to a variety of critical tasks. Thank you for watching. If you have any question, please contact me at mohammed.hussein20@msa.edu.eg and take a look of my portfolio. I'm going to leave it in the description.